Hello. Today I will be doing some chapter 1 review for Algebra 2 Honors for finals because that's coming up. So excited. And chapter 1 was such a long time ago, so I just want to get some review in. And I also think this is nice because we can revisit some problem topics. And I'm looking back at it and it doesn't really seem that bad, so we'll see. We're starting off on the chapter 1 review on the side. This is number 32, so you can follow along if you like or not. Alright, so basically we learned just have to take the cube root of this. So the cube root of 64 is 4. So 4, and the cube root of 8 to the 18th, that would be 8 to the 6th, then b to the negative 3rd. And then we have to leave it like that. You have to move that to the bottom. And then that's correct. Alright, let's try another problem. Problem right after that, number 33. Root 3x over 2y cubed. Okay. So this would be root 3x over root 2y cubed. And I like to just put this here, so that's this. So we want to get this simplifiable so we can rationalize the denominator. So let's see, if we add another 2y, so that would be 4y, 4. Yep, so that would work. So this would be 6x. Alright, so this we can simplify now, we can rationalize it. So the square root of 4 is 2, the square root of y to the 4th is y squared. And then we do the same to this. We can't do anything, sorry, so it's just this. I don't know if that's right because I haven't done this in a really long time. But I think that's what we can do. And of course we got it right. Alright, so for this next problem I was kind of confused, but it's all good. It looks kind of confusing, but as long as you don't overcomplicate it and you just know your exponents, you'll be pretty good. So I'll just explain what I did. So see negative exponent here, you just want to bring it up. So now you have that. And then you have the fractions and you don't want to convert it. You want to leave it in fractions. It'll be easier. So for this, you can make this one term actually, because you can find the common denominator and add those. So this you would find 10 to be the common denominator, then you would add these when you multiply them kind of. And then you would get negative y to the 9 tenths squared. So then you would square the negative, so it would be positive y, and then you would multiply the 9 tenths by 2. You multiply the 9 by 2 and the 10 by 2. Then you get this, and that simplifies to 9 tenths. At least I'm pretty sure. Okay. And this is right. I'll load this up by the way. You can simplify it to this if you want. Actually, because wouldn't you be able to take out 5y's? So take out 5y's, and then you'd be left with 4. Oh, that's also correct. I don't think so. Alright, let's try this. $45. And we have to express this as a polynomial. Wait, okay, let me actually use another number because I already did this one. 10. Just change this to 12. Okay. And I don't know why this is. Alright. So what do we do? For this we can factor out, right? Oops. Oh my god. Right. We can factor out x, y. We can just factor out x, y, z. Yeah. So we have 12 x plus c squared minus y over x. These two would cancel out. And this would be your final answer. And of course it's correct. Moving on. All right, let's do some chapter 2 review. Let's move this on to another page. Okay. All right, let's try number 1. Okay, so we already know that there's a 4 and a 3, so that means that we can use the number 12. So we use 12. We have to use it for everything. So by multiplying this all by 12, we get 12 divided by 4 is 3x, plus 12 times 4 is 48, equals 36 minus 4x. X equals negative 12 seconds. Let's try one with variables now. All right, number 4. All right, so what we can do is factor out. So let's just rewrite this. Let's take out 4, 5x plus. So this is 5x plus 1, this is 5x plus 1. So this is 5x plus 1 times 4. This does not have a 4, so we need a 4 here. This is good. We need a 5x plus 1 and a 4 here. So wait, hold on. Okay, so you want a 5x plus 1 here. And then this is getting, because you can just do, okay, so we will want to multiply this. So this is 20 over 20x plus 4. And then we would be able, so actually, let's just write this as like this simplified. So we can cross this. So that's just 20, like I'm just showing it out, just so like it's clear. So this would be 3. And then you would multiply this. So we have 20x plus 1. So 60x plus 12 over 2. Alright, so x is 11 over 3. So I was just asking if there are infinitely many solutions, give the restrictions on x. So since there are not infinitely, we do not need restricted values. Okay. But the answer is, right. Alright, let's do some word problems. I feel like these are like the hardest for me. So this is just like distance equals rate times time. Okay, so a runner starts at the beginning of a runner's path and runs at a constant rate of 6 miles an hour. 15 minutes later, a second runner begins at the same point running at a rate of 8 miles an hour and following the same course. How long will it take the second runner to reach the first? Okay, that's kind of messy, sorry. But, so, it's like the same path, meaning their distances, yeah, right, because their distances should be the same. So, distance equals rate times time, which means that rate times time equals rate times time. So, rate times time of the first runner, 6 miles an hour. 8 miles an hour, okay, wait. So, this is 15 minutes later. So how long will it take the second runner to reach the first runner? I really chose an interesting problem. Okay, wait, I get it now. So this is 15 minutes later. So this is like minutes, so it would be like 15 over 60, 0.25. So like the time, we're trying to figure out the time. But we know that the time should be 15 minutes later. So let's try like, so the time of this runner, time of this runner, the time of this runner is just 15 minutes later. So let's just try this. I don't know or believe that it's right. So we can still give it a try. So wait, what? Okay, sorry. T equals 1. So it should just be 1 minus 0.5 then, I guess, or 0.75, which would be 45 minutes. Let's see if 45 minutes is the correct answer. I don't think that it's the right answer. Oh, it's right. Okay. So, oh, my screen is like frozen. But it is the right answer. So you just really need to know distance equals rate times time, and like if it's like on the same path, like when they meet up, they will have to have run the same distance. So the distance has to be the same. And then like it's 15 minutes later, 15 out of 60, 0.25, blah 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 blah. Kind of just fake it until we get it. Okay, this is right. Next word problem. 2 children own two-way radios that have a maximum range of 3 miles. Let me actually use a highlighter. One leaves a certain point at 1 p.m., walking due north at a rate of 6 miles an hour. The other leaves the same point at 1:15 p.m., traveling due south at 9 miles an hour. For how many minutes after 1 p.m. will they be able to communicate with each other? Okay, so the range is 3 miles. So it would have to be like, so like this is like a certain point. This one is walking due north, one is walking due south. And then this has to be 3, this is so ugly, 3 miles. Anyway, so this is equal to time. So the distance, D1 plus D2 has to equal 3 miles. And then rate times time, D1 equals 6t, D2 equals 9, and it would be 15 minutes later again. So it would be 0.25. It would be t minus 0.25. Let's just go with that. Okay, so now we can just hopefully set it up. Again, I'm not confident with this. That should basically be right. So you just like kind of plug this into here. So 6t plus 9t minus 0.25 equals 3. And that's okay. So according to my calculations, that should be 21 minutes. Let's see if I got it right this time. I don't wait. I don't know if it's right. And it's right. I'm just like that. Okay. So that's right. Let's see if there's more word problems. Oh, by the way, this is on the review, the final review guide for chapter 2. Hello friends, after chapter 3, yeah, sorry, this question on the review design. So basically, we have a standard equation for parabola as the vertical axis and set size given conditions. These are given conditions, and we start writing some numbers. So the real answer is and it passes through the equal. So let's just plug in. Oops, I can't do that. So this should be the answer. Now we have the coefficient. That should be the answer. Because we put it in vertex form and we put in the points test. Yes, that's correct. That's the answer. All right, moving on. I guess we do some of these too. Because if I did form of the equation, the line goes through the point. So it goes through. It's perpendicular. Choose. Okay, so it goes through the line. Let's look at this first. So f equals negative 5x plus e. And it goes to negative 5x. So this should be wait. I did something wrong. Right. So is that correct? Okay, I think. Yeah. Okay, it says find the general form of it, thing standard for. So I have to put f into a plus b y equals c, which is really stupid. I think that's just really stupid. Okay, thanks. X plus y. Wait, that was really easy. Okay, that has to be right. Sorry. Right. Is this correct? Any other ones? Some of these have graphs on one side and not drawn out. So let's try to do some domain ones. Oh, this one's really good. Okay. How do I quit? So find the domain of this. Okay. So let's find the domain. We have to really think like what can't x be. So the denominator can't be 0, so let's figure that out. And also the numerator cannot be less than 0. Let's figure out the denominator, so we use that. Okay. So what I'm talking this out. 10 x squared. Okay. So x cannot be 10 or 1. And then for the numerator, it can't be negative. So let's set this up as inequality. It has to be greater than or equal to 0. So x has to be greater than or equal to 11, right? And this is number, so it's in interpolation. So let's try the number because I have to visualize. And number 8 is like, oops, somewhere in between 1 and 10. No, it still can't be 1. Okay. And x has to be greater than or equal to 8. So it can't be less than that. So that's 6 is 11. Okay. So it can't be 1, but it can't be anything less than 11 anyways. So that's just why that's not going to include. The interpolation should be 11 over 8 to 10, bringing in 10 to infinity. Yes, that is correct. Ooh, okay. Transformations I'm really bad about too. Y equals 5f x minus 4. So how does this compare to y equals f of x? Good question. So this would mean that it's shifted to the right, to the right 4. And then this would mean that it is vertically, right? Vertically. Would that be a compression or a stretch? I think it's a stretch. I think it's a stretch. It would be stretch, right? Because all the y values, like, it would be multiplied by like 5. So like, if the graph was like this, it would be like this. So like, that's like stretch. And I'm literally right. Okay. Next one, also transformations. Keep your we're using 14 pages. That's crazy. So that means because I'm not using pages. We have this here 2 y equals 7x. So this is down 7. Okay. After, so it does like after like this x is negative. So they do like different things with the analysis. Okay, well it's not stretch or compressed out. It's just reflected. So like if we think about this, like if we did f of x and then f of negative x, just like for the example, f of x is like, I think like, actually no. I think it's x. I think it's reflected across the y axis. Actually no. So the x negative. So it was f of 6, then it would be f of negative 6. So it would have to be reflected across the y axis, right? Because that's the terms of like negative. But if we were like f or negative, I would put negative like this. And up to the bottom, I'm just going to say that it's down 7 and reflected through the y axis, which is right. So I'm going to have to brush up on that a little bit. Oh my god, there's another problem. That's transformations. Alright, this is going to be the last one. Oh, wait, this is so, the negative. Oh, wait, okay, that actually makes sense. Like, I was like, now I get the last one. If you have a negative f, you reflect across the x-axis because, like, that's like, it makes sense. Like, it doesn't have, like, it affects that axis. I feel so, like, I don't know. Okay. So this is reflected across the x-axis. This is, and stretched. Yeah. This is, like, in parentheses, and it's, like, in there. So I think this is, like, horizontal compression. This is, like, on the multiple edges. So I think it's horizontally compressed, but it's, like, moving like x brackets like this. Because it's not, like, on the f, it's on x. So that would be, like, okay, this is my second process of elimination. So I have to stretch horizontally by a factor of 3. So, yes. So doing the x-axis and stretch vertically by a factor of 2. That sounds correct to me. Alright, yes, that's correct. So luckily for the test, this is probably a multiple section, so I'm going to do it. Let's do some functions. Let's do a difficult one. Okay, let's do that. Okay. Number 43. Number 5, f of gx. That would be 8x cubed. That would be 4x cubed. Just 4. So that would be 16x cubed. Now find the g of x. Which seems to be 1. Actually, not really. Alright, so hopefully these are right. Counting on t. Find f of g4. Okay, I forgot to put this in. There's a second. So just right, next. Right, another one. So it's other TX. Let's see. I think that's like, I think I'll just do that, right? Because I don't know if there's something like that. I think so. That's wrong. It is wrong. Okay, so that's UX of that is that. Ooh. Oh, I was literally right. Okay, this right is not. So this is right because you can't combine this. It makes sense. Okay, I was on right. I was literally right. So find the domain of this. The domain of f of g. Okay, does f of g just mean? What does that mean? I'm supposed to say right now. I think it's not the domain of f of g of g of x. So I'm just trying. I have it in some mind. Okay, so f of g. Wait. Okay, they're literally asking me to find the domain of this. Right. So right. So next, find the domain, and x cannot be anything less than negative 10. Let's change the That's it, right? That's all it can be. If you're trying to get less than that. So I can just move to the page. Okay. So one thing about what is when you click answer, when you unclick it, accidentally click something. Okay. So let's find the domain of g of f of x. So now you're finding out what it is, or just oh, yeah, yes, find the domain of g of x. Okay. So g of x. That's what I say. Wait. Yeah. Can we? Okay. Wait. Yes, I got two. And the domain. Okay. So x cannot be. So x must be greater than equal to 5. X must be greater than equal to 2. That's one line. Here's 5. Here's 2. So x must be greater than equal to 2. And x must be greater than equal to 5. So, but like, is it like, wait. Okay. So that's not because like this. It would be like this, but it can't be less than 5. Because otherwise it'd be 0. Wait. Yeah, because then we negative. If this number, if this like 50% is negative, so it cannot be anything here because 4 like 4 before minus 5 is negative 1, then create negative 1. So that means that the domain has to be 5 to infinity. Wait, just that's not an option. That's literally not an option. I think I know what the option is though. I think I know. Okay, I do know. So in this case, I think you have to use like I think it's like the like less than equation or something like that. Because also I think like that's checking or whatever, or just use common sense. Anything less than if it were like less than 2, it would create 2 positive. So that would be fine. But nothing here would work. Alright. Like I think the best way was to be like I was saying you would just do what you like do with like examples. Like I think that's what we did like average. So like checking which interval like works. That's what I would do. So I would be like is 1 make this negative? No. So this work does like 3 make this negative? Yes, it does make negative. So no work. Does like 6 make this negative? No, it doesn't. So the domain is negative 52, 5, and infinity 2 even 5 to infinity. Perfect. Hello. We're going to be doing some more chapter 4 review. So this is out of the textbook. This is page 289, question 40. So this is what we're given, and we have to find a rational function that satisfies these conditions. So let's first look at the vertical and horizontal asymptotes. So this is the horizontal asymptote is the ratio. Well, since it is 3 halves, we know that it has to be a ratio, so it has to be this, and we know that the degrees have to be the same because y isn't 0, so we know that it has to be that. So then we know that there's a hole at x equals 2. That means that this is on the top and the bottom. So next, we know that the vertical asymptote, this is it. That would be x plus 3 because it cannot be negative 3. And since there's a hole here, you just would not count that as like because like that's already a hole. So that would be part of the vertical asymptote. And then we know that the x-intercept is 5. So that means that you would set this equal to 0. And like since this is like already a hole, like the x-intercept, so it would be x. Sorry, it would be x minus 5, I think, because yeah, because you find the like you would set this whole thing equal to 0, but when this is 0, the whole thing is 0. So how would you get this to 0? Well, if we know that this is 5, then we know that like x minus 5 if x were 5, then like this would be 0. And all of this would be 0. If that makes sense. So this would be the answer. Moving on. Let's sketch some graphs. This is number 30. Let's graph this. Okay. So horizontal asymptotes, vertical asymptotes, x and y intercepts. So horizontal asymptote, since this is not the same degree, then we know that y equals 0. The vertical asymptote is just what x cannot be, and it cannot be negative 1. Sorry, wait, x equals negative 1. Alright, so let's draw the asymptotes. So, okay. Now, there is no, what's it called, there's no x-intercept, but we can figure out what the y-intercept is, right, because, so, and then 0 plus 1 will just be 1 times 1, so that would just be negative 2 over 1, negative 2, so the y-intercept is negative 2, which is right there. Okay, and then let's go into, like, okay, I literally don't know where this line is, like, let me fix this, actually, wait. Yeah, let me fix this. What are those two? Okay. And then that would be wait, this looks better. And now let's like plug in a point on the side of the asymptote. So let's plug in a point like maybe 2 maybe. Negative 1 plus 1, negative 2 over 1, negative 2. So negative 2 just be negative 2. Interesting. Okay. Let's try like negative 3. So that would be like 1 negative 2. 4, negative 2. So negative 1 half. So where is this? This is the right way. Negative 3. This would be negative 1 half here. So we can then just assume that it's going to do this. Because what else would I do? And then so this one we would have to plug in more points. So let's plug in points here. So let's try 2. So we have 3 times 3, which is 6. Negative 2, 6, so like negative 1/3. Doesn't really matter. Okay, let's try like something 1, 2, 3. Let's try like 4, just to see like where we're at. So, oops. Seems kind of trivial, but I'm just writing it down. So that's 5 times 5 is 25. Okay, so negative 2, 25. 25th. So that would be like awfully close. But not touching because, right, because it cannot, no, the vertical asymptote it cannot cross, but it can cross horizontal. So let's just see if I did this correctly. I did it correctly. Yay! Did it correctly. Okay, next question. Okay, this is gonna be annoying. Let's try. Wait, this looks like. Okay, so we have to find all solutions of this equation. So what we would do is yes, so everything, all factors of this. So that would be not all plus or minus. Plus or minus 1, 2, 3, 6 over plus or minus. Hold on. Never mind. And then I just keep plus or minus. Okay. This is right, I think. Anyways, I don't feel like doing this, but it's fine. Okay, so first we would do. Okay, so like this is all. It's literally just 1 plus or minus 1, 2, 3, 6. So let's try positive 2. And then let's investigate. So 3, 2, 1, all the degrees are there. So 1, 1, negative 7. And we first try. Okay, so we got that 2, x minus 2 is a factor. So that, then this is like what we are left over, and we still have to like figure this out. And we can actually just factor this, but like if we couldn't, then we would just look here again, factors of this, look here, factors of this plus minus. So we just factor this. Okay, so we found out that x minus 2 is a factor because we checked and we got it first try. And then we got this is like this. This is the leftover. We could like try and guess and check again by using this because these are the factors of this over the factors of this plus or minus. But we can also just factor this out because we can just do that. So then we would get this, and then we can factor this. And don't forget about this. Oops, we really wrong. All right, and because it's a fourth degree polynomial, make sure to always be checking to make sure you have the right amount of solutions. And we got it right. Yes, yes. Okay. Three has the zeros, -2, -1, 0, and or f of 4 equals, sorry, f of -4 equals 72. So we can just convert these into factors. So that would be x plus 2, plus 2, x plus 0. And it doesn't say the coefficient, so we put a, and then this would equal 0, right? So, well, since f of 4 is 72, we would plug in -4 for x. So then, so -4 plus 2, -4 plus 1, -4. So -2, so that's 6 times -4. So that would be -24. A. And that would equal 72. Okay, sorry, because I just did not put the 72 in. I thought. So then 72 over -24 is -3. So then it would be 3 x plus 2, x plus 1, x 8. And then we can make this into a polynomial, so just be of x. And so then the final answer. This final answer, let's put it into a website. And of course we got it right. Next, let's try another one. Okay, number 24. A polynomial f of x with real coefficients and leading coefficient 1 has a given 0 centigrade. Express f of x as a product of linear and or quadratic polynomials with real coefficients that are irreducible over order numbers. And the given zeros 2, -2, -6, and the degree is 3. So we know that the degree is 3 because we see 3 factors, x minus 2, and then we know that this is a 0, so the conjugate is also a factor. X minus 2 and -2 minus 6i, and the conjugate x minus -2 plus 6i. And then let's just distribute -6, x plus 2 plus 6i. Oh, hey, that's difficult. X plus 2 minus 6i. Alright, then we just have x minus 2. Let's not forget about that while we distribute here. Alright, so a bunch of these are going to cancel out, of course. That's going to cancel out. That's going to cancel out. So then we just have -36 squared, that's just 36. So 36 is 40. And we have to cross them out, so then we would have x squared plus 4x plus 5. So, okay. And then we would just have x minus 2. So, okay, actually, we did not have to do, actually, yeah, we did have to do that, but we can just leave it like this. And I think y is we'll take it. So. Okay, it works. Of course, it is correct. Alright. So, 29 asks, does there exist a polynomial of degree 4 with new coefficients that has zeros 3, -3, 100, and I? You know that the factors are x minus 3, x plus 3, x minus I, and x plus I. This would be a difference of squares, so that's a squared minus b squared. So a squared minus b squared. That would be x squared. Negative I squared is just negative x plus 1. And this is also a difference of squares, so it would be the same thing. So x squared minus 3. Does there exist a polynomial with real coefficients? Yes. Okay, and we got it right. Moving on. Alright, number 31. It's good we didn't do this one because it's something that I struggle with. So, we have f of x equals negative 4, x plus 4, x minus 7, x minus 2, x minus 7. So, we have to identify any vertical asymptote. So, what would that be? First, we have to realize that there's a hole here. So, since these two are the same, we know that x can't be negative 2 or negative 4. Sorry, x can't be 2 or 7. So, the vertical asymptote, 1 would be x equals 2. But since there's a hole here, x minus x equals 7 would not be a vertical asymptote, it would be a hole. And then that's something we'll plug that in. Horizontal asymptote, the degrees are the same. So it would be ratio, which is negative 4 over negative 4, negative 4. So that would be y equals negative 4. And the hole, well, we'll just plug in the x. So you know that that's going to cancel out. We're just left with this. So 4 and then 37 over 7 minus 2 times that's 11 times negative 4, which is 40, negative 44 over 5. And we can't really simplify that. That's like negative 8.8. And of course, we got it right. Chapter 9. So I already have a problem set up. This is a system of 3 equations, and this is from the little homework sheet of like the system of 3 equations that we got in class that one day. So I think this out. Let's start and see what we can do. So I already noticed that there's like negative 2y. Well, so that's just really interesting. Anyways, let's just take 2 of these equations and cancel out some terms. So negative 2y and negative 2y we can just subtract, and then we cancel them out. So for this one, we're doing the first equation minus the second equation. So that would cancel out. Negative 6 minus 3. That would be negative 9x equals, 2 minus negative 4 plus 6z equals negative 8 minus 8, negative 16. Now that we have the y term canceled out, let's use another set of 2 equations, 2 systems to like cancel out terms, to cancel out y as well. So we can then take those 2 together and cancel out more, if that makes sense. So then this would be the second equation minus the third, yes. Okay, so that drops out. 3 minus 6, negative 3, x, negative 4 minus negative 6, 2z, 8 minus negative 8. So 26. Now let's just take these 2 and then like set them up together. So negative 9x plus 6z equals negative 16. Negative 3x plus 2z equals 26. So I'm just going to multiply this by 3 so we can get the 6z. Negative 9x plus 6z equals. Alright, so this is really interesting because we have negative 9x plus 6z twice. So like, wouldn't that be like no solution? Because you can't have it equaling negative 16 and 78. Okay, well let's just see. So we can get rid of x by taking negative 9 minus negative 9. So minus, that would cancel. So 6 minus 6. So that's all. So now we have like 0 equals whatever like this is. So yeah, this would be like no solution because there is no like solution between these. It can't equal negative 16 and 78 because both of these would cancel out when you subtract them. And let's just see what the actual answer is. I don't know if you tried to like cancel out some other terms, like how that would turn out. Yeah, so this one is no solution. So this is between a circle and a line. It's funny because it also just like looks like that, which is really funny. Okay, so that means that at most it can have 2 points of intersection, which is just something nice to know. So, I keep saying so. But anyways, let's use substitution. So, I did it again. -2y. So, yeah. So, x would equal 2y minus 4. Then we just plug in. Yes, okay. So 2y minus. Okay, this just like looks wrong for some reason. I don't know why. No, let's just find x. Okay, let's see if this is the correct answer. Yes, it is correct. Moving on. Okay, next, this one is linear programming, which is like, ooh. So like, this is like a word problem, and it's like a manufacturer of cell phones makes a profit of $25 on a deluxe model and $29 on a standard model. Okay, so that's just the profit. And I'm pretty sure that's like, okay, so let's assign our variables. The company wishes to produce at least 80 deluxe models and at least 100 standard models per day. To maintain high quality, the daily production should not exceed 270 cell phones. So how many of each type should be produced daily? Okay, so I'm just going to graph this to solve it, and we can use x will be deluxe, y is standard. So at least 80 deluxe models, at least 100 standard models, and the daily production should not exceed this many cell phones. So 270. Okay, what? Never mind. I'm just thinking this can be like 100. Wait, okay, I don't know. I literally just might put this into Desmos because that's what I did for like some of the like rest like for like these problems because I don't know like the numbers are like large and I don't really want to make like a graph that big. So I'm just gonna use Desmos. It's faster anyway, and it's so easy to use. I know we won't have Desmos on the test, but like whatever. Like I hope she wouldn't do this stuff because I don't feel like this. I don't feel like doing all that. Okay, so let me just. All right, there's like this the triangle that there should be with like the 3 points, and the triangle's like the best like for the profit. So the points we have are 80, 100, 80, 190, and 170, 100. So these are the points where we kind of have to plug into the profit equation to figure out which one is the best. So the profit equation is just 25x plus 29. And then let's just plug in some points, plug in like the data. Wait, wait. Oh, wait, wait. I actually have to add them. I literally didn't even add them properly. Hold on. It's this one. So that means that there should be 80 deluxe and 190 standard, please. I have to find like the weather sign. Oh, and it's right.